vision and time series analysis. Plus, you will have uh, mobile development lessons. Okay, and of course, you will continue with design workshop from April 12th. Okay, do you understand?
Thank you, understand.
Okay, Ali. Okay, we can see.
Okay.
Okay, please start.
Yes. Today, talk about underwrite digit recognition. First of all, introduction. Handwriting digit recognition is the ability of computers to recognize human writing digit. It is hard task for the machine because handwriting digit are not perfect and can be made with many different flavors. The handwriting digit recognition is the solution to the problem which use the image of a digit and recognize the digit present in the image. Convolutional network have advantage in image processing in all neural network. Handwriting digit recognition is divided into online recognition and offline recognition. Online recognition refers to letting the computer recognize the characters written on the handwriting device and recognize it on the basis of handwriting strokes and stroke order. Their theoretical research of the technology is very metry. Offline recognition is the recognition of characters written on paper by the computer. There is stroke and stroke order as the basis. Only the picture recognition provides less information, so it is still fucking greater challenges. And this figure about the flow chart of the handwriting digit recognition system. Now talk about the MNIST dataset. The MNIST dataset is an acronym that stands for Modified National Institute of Standards and Technology dataset. This is properly on the most popular dataset among machine learning and deep learning in the SIST. It is a dataset of 60,000 small square 28 bar 28 pixel. Graphical image of handwriting writing as a single digit between 0 and 9. So the MNIST dataset has 10 different classes. The MNIST writing digit classification problem is a standard dataset use the computer vision and deep learning. Although the dataset is effectively solved, it can be used as the basis for learning and picturing how to develop evaluates and use convolution deep learning neural network for image classification for Scratch. That includes how to develop repeats test, Harins for estimating the performance of the model, how to explore improvement to the model, and how to save the model and later it make a prediction on new data. And this code can show this number. Yes, now steps to implement the handwriting writing digit recognition project. 1, import the libraries and load the dataset. First, we are going to import all the models that we are going to need for training our models. 2, pre-process the data. The image data cannot be fed directly into the model, so we need to perform some operation and process the data to make it ready for our neural network. The dimension of the training data is 22 or 28 or 28. The CNN model will require on more dimension, so we reshape the matrix to hope 28.1. 3, grade the model. We will grade the CNN model in a Python data science project. A CNN model generally consists of convolution and polling layer. It's work better for data that are represented as great structure. This is the reason why CNN works well for image classification problem. The dropped layer is used to deactivate some of the nerves and while training. It redux over fighting of the model. And 4 and 5, train the model and evaluate the model. Now talking about CNN algorithm, convolution neural network are representative algorithm and deep learning. It is essentially a multi-layer prescription the smelters local perception to achieve an input to output mapping. It extract the characters of the data at different SQL through multiple convolution and polling. What is NQ in the CNN network is the way used in local connection and shared weights. On the one hand, it reads the number of weights, which make the network easy to optimize, and on the other hand, it reduces the risk of overfitting. Yes, CNNs are generally composed of their metally supported levels, namely convolution layer, polling layer, poly-connected, and soft max layer. Yes, this figure about neural network model diagram. Convolution layer. In the convolution process, we get local feature science of the convolution layers is composed of multiple convolution units in the collection process in order to extract more feature about the input parameters. It is necessary to obtain more complex feature correlation values from low-level convolution layer through multi-level cascading, and to sampling layer. On the one hand, the sampling layer can improve the fault tolerance and turning speed of the models. On the other hand, it can read the number of data and parameters through features dimensionality reduction to achieve the effect of reducing overfitting. It compresses the input feature map. The main function is to perform a feature compression, extract the main features. Now, fully connected output layer. The rule of the fully connected layer is critical. All features are connected through it, and the bonding output values is sent to the classifier. It uses the extract feature parameters to classify the original image. After multiple layer of convolution and pooling operation, the resulting feature map are sequentially expanded by rows and connected into a vector input to the finally connected network. Yes, and collection in the artificial, we have successfully built a Python deep learning project on hand writing digit recognition app. We have built and trained the convolution neural network, which is a very effective for image classification purpose. Later on, we build the GUI where draw a digit on the conveys then we classify the digit and show the result. Hand writing digit recognition has been treated as a multi-class classification problem in the machine learning context, where each of the 10 digit 0 to 9 is viewed as a class, and the machine learning task is essentially to train a classifier that can effectively discriminate the 10 classes. Yes, and now this reference, the end. I am finished.
Yes, thank you very much, Ali. Please, a question for Ali, Vasily. Do you hear us? Vasily?
Some noise.
Yeah, some noises. Okay, I think, well, and do you have any code in Colab or not today?
Yes, of course. I have a workshop.
Okay. I think all fine. And
you hear me now or not?
Yeah. Okay.
Yes, good.
Okay, everything is correct, but the main idea that you should apply your research to your study to face processing, yeah, and this is the last task. I mean that gender and age classification. Of course, everything is correct now, yeah, but I want that you prepare the last task for the next lecture, okay? Ali?
Again, Professor? Last task?
Yeah, I mean that the main task is apply this model, this convolutional model for age, gender, and race classification. So I hope that you prepared the last task. I mean that this architecture to
understand, Professor.
Okay.
I am waiting for update the task.
Yeah, sorry, I forget. So, okay.
But I'm now, I have a task about handwrite.
Okay, I understand. Everything is correct.
Because I wait the update.
Waited for, okay, I understand. Maybe today, maybe tomorrow. Okay,
Okay.
I update it.
Okay.
I forget for this week. Okay, maybe who do you have any questions about your task? Maybe it will be more useful if you just write some questions about the task and some problems or not understandable moments in our task. Who?
No. I think maybe I should write write some information about head digit.
Okay, I understand.
You write it.
Okay, now you just wait the last task, yeah? I mean that the last task, it will be one architecture, one CNN, one convolutional neural architecture for gender, race, and age classification, and we just try to train this model for all tasks, yeah, using UTK data sets, UTK basis data sets for this, yeah. So I understand. Okay. Maybe. Okay, Vasily, do we have? Will we have workshops after this half semester in the next half, or not? Oh, we don't hear you. Vasily, we can't hear you.
Yes, of course, we will have a workshop at second half semester, each weeks, of course, in same regime.
Okay, I understand. So, maybe I just draw some idea the last task here, and after this I try to append notebook for this task here. So one moment.
Can I send you my workshop?
Yes, of course.
Or check?
It will be best if you send your workshop. And but now we just discuss some idea. Printable documents. And so just I remind you the main idea that now we have some feature extractor. Yeah, here is some picture with face. Yeah, face, and we use feature extractor, which consists of some convolutional layers, and we will get some features. And after this, we use classificator, which consists from fully connected layers. Yeah, fully connected layers. They look like this. And if we solve the task, for instance, gender classification. So we have just two neurons, yeah, something like this. Two neurons which output, for example, these neurons show us that this is a female and this one male, yeah, male. So this is just a common scheme how we can create classificator for gender and race. And let's draw like this, like a arrow. Yeah, we just put features from the feature extractor to our classificator. Yeah, classificator from fully connected layers. Yeah, and of course we can use more than two classificator for this feature extractor. For example, we can create another classificator with fully connected layers for race classification. It means we have 4 neurons, something like this, yeah. And we will have 4 classes, if I remember correctly, 4 classes with race. Yeah, this is a gender, gender. This is a race, and we can use the same features put into this classificator and classificate classes, for example, 1, 2, 3, and 4 here. They return probabilities, yeah, probabilities for each classes, and you can use more than 2. You can use another classificator, for example, for age classification here. Yeah, if this is the main idea, and of course you can complicate your architecture for different tasks. Now we use loss function for changing weights from the gender, for instance. Yeah, for example, loss which is cross entropy loss. Yeah, for gender classification, but we can use more than 2 loss. Okay, this is loss 1, this is loss 2, and to gain cross entropy loss through the race classificator, and we can combine them together into loss like this, loss 1 plus loss 2, and it means that you will change weights your classificator and weights your convolutional models from this path and from this path, and your model will be trained to classify gender, race, and of course here we can train age classification, for example. So it will be the last task for this, I guess, and it's just a common task, classificator image classification, and I guess that it is advanced level for creating model when we use more than one head. It is we can call this is like a head, because it is like a classificator with fully connected layers, and this model will have three heads. Yeah, 3 heads, and we just with one neural network we solve 3 tasks. But I guess that the accuracy will be lower than we solve just one task. But I guess that it will be nice experience to create such complicated model for you. So okay, I write the data sheets and notebook for you, and write the task. I try to write in details how you can create such monster convolution. Okay. The main idea, I hope that's understandable here. Yeah, that it is a separate classificator using just one feature extractor for classificate gender, race, and age will be age. Some neurons here. Yeah? So I hope it is understandable. I try to append tomorrow, and I hope that you will have some small results to the next week, because it is a complicated task. Yeah, complicated task maybe, and I think that there are some problems, maybe some for implementing, but we will try to solve them. And after this task, we try to go to segmentation. And segmentation, I guess that for segmentation task we will try to use some medical images, but Barak is absent, and I get that we can use people segmentation. Maybe it will be more useful for you. People segmentation, I just try to find some data sets where we have person and the mask of segmented, and we try to solve the task for segmentation. But of course, the same task will be in our course computer vision. I guess we have some maybe the same task. Maybe I try to do something more interesting. Maybe I add anything, but this is a task from the computer vision, of course. Yeah. Okay, maybe you have any question? No.
For a new task for this, no, maybe later.
Okay. Okay, and so okay, we decided that I append tomorrow, and I just add some text and in detail task for you. So.
Okay.
Okay. Maybe any question?
And we have some time. Can you send my workshop?
Yeah.
Because
Of course.
I have a question about neural network handwrite.
Yeah, please show your screen.
No, show. I will send.
Or maybe send your
Yes.
Your homework.
Okay.
To Vasily, please.
Yeah. You can send me on my mail, okay?
Email or now?
Please send in chat of
maybe in chat.
Teams chat.
Yes, moment. First question, Professor.
Yeah.
I change my run because GPU stop from source.
Stop from source.
Yes, 3-day Google Colab stop.
Yeah. Interesting. Why so? Okay. Now we can use GPU. Okay, 0. So list. Okay. Yes. Okay, process row.
And I am added 3 neural network convolution and
This
3,
different model.
but not correct. I
Okay.
have error like this now.
So I hope that this picture is understandable for you or not. This one.
Yes, I understand this.
Okay. So I just test loader. No test loader. Where is the test loader?
This error in chat and
Yes. Okay. Kernel size can be greater than actual input size. Yeah. This is a problem because. Okay, one moment. Test loader. I forget.
and this error.
Yeah, I understand. So the first problem.
Sorry, I try
Yeah.
kernel size 3, not 5.
Yeah.
The same.
It should be noted that if you, okay, maybe better if we write like this. For instance, here, if we have some features here, features like this, and we use some kernel, for instance, here, and here, and here. We just calculate convolutional through all features. Yeah. For instance, this is feature maps has 16 on 16 and kernel size 5 by 5. Yeah. So here we can calculate convolutional through all features. But if your features is 4 by 4, you can't fit your kernel size 5 by 5. You can't here, yeah, because the feature maps is less than your. Okay, this is a feature map. This is a kernel 5 by 5. You can't calculate here. There are some way how we can calculate it. The first way, if we add padding. Padding means we create some, for example, padding rows and columns with zeros. It means that everything 0 here, yeah. Okay, but just 6 zeros. And now our feature maps will be 6 by 6 because we add padding row with zeros here and padding rows here, and we add 0 column here and 0 column here. So after this we can calculate kernel size. But for this you need to add padding here, yeah, padding, for example, 1. It means that it means that you just add additional line and row
understand.
everywhere. This one way. The other way is get less kernel size, and I guess that this is the best way because in computer vision oftenly not use kernel size 5 by 5. It is not a good way, because better it means that 5 by 5 just one convolutional layer, yeah, convolutional layer. In computer vision oftenly use 3 by 3 and 2 times. It means 2 convolutional layers, 2 convolutional layers using kernel size 3 by 3, because if you use 5 by 5, you can see the area with 5 pixels by 5 pixels. If you use 3 by 3, you can see 3 pixels by 3 pixels. But if you use 2 convolutional layers 3 by 3, it means that you can see area 5 by 5, because sorry, I guess it will be better if we look like this, yeah. For example, this is a kernel size 3 by 3, and we convolve our pictures 3 by 3, and after this we can convolve, for example, for these pixels 3 by 3. It means we can see in area 5 by 5, yeah, because you can convolve here, and convolve here, and you can see something like this. And this area will be 5 by 5 too, because this is the 2 convolutional layers 3 by 3. So the receptive field, it is called receptive fields, you can see in area 5 by 5, but here you have 25 weights, which you should collect and storage in your GPU. 25 weights, because 5 by 5 you have 25 weights. But for 2 convolutional layers 3 by 3, you should collect 9 plus 9. It will be just 18 weights, and you can see that we storage just 18 weights, but we can see in the same field. So kernel size is 5 is not good, but better if you use 2 convolutional layers, convolutional layer 1, convolutional layer 2, and after them you can use max pool. This is a must-have maybe for any model, for example. Yeah, there are a lot of models, for example VGG and etc. VGG 16 or 19, where we can use pair layers, pair or 3 layers with kernel size 3 by 3, and of course it should be noted that if you have, for instance, feature maps 4 and you use kernel size 3 by 3, like this here, 3 by 3, you will get, after convolving, feature maps 2 by 2, yeah, because your kernel size will be stay here, and here, and you will get feature maps 2 by 2. There is one way. If you add padding 1, it means you just add 0 padding through the kernel size. Your kernel size will be stay here, here, and here, and sorry, one. Maybe it will be more clear if we write like this. For example, so this is a feature maps 4 by 4. We add additional 0 padding, and we use kernel size 3 by 3. It means that we can stay our kernel size here. It will be looks like this. After convolving here, we go move our kernel size in these pixels and this and in this. And after convolving, we get the same size, 4 by 4. It means that if you use padding 1 and kernel size 3, you will get the same size, 28 by 28 will be 28 by 28. Because additional, when we add padding 1, it means that we can convolve our feature maps into the same feature maps, into feature maps with the same size. So in this way, just help you not recalculate the size of feature maps. You can understand that padding 1 and kernel size 3 always get the same size of feature maps. 28 by 28 will be 28 by 28, and etc. So there is another property which is called striding. Striding means you can move your kernel size. Okay, it should be noted that striding by default equal 1. It means that we move our kernel just one step, yeah, to one step. But of course, we can use striding, for example, 2. It means that we go our kernel size here, and we try to go here what we can, because we can calculate our convolution in this part of image. But we can stride the kernel size on any step. So, and of course, when we use striding 2, it means that the new size of feature maps will be decreasing in 2 times, yeah, because we just go by 2 everywhere. So I recommend you remove kernel size 5 and trying to implement kernel size 3. Okay, maybe we just let's look here. Okay.
Sorry, Professor. I am change 5 in 2 or 3.
Yeah.
And the same error.
Yeah. Okay. Let's see. Maybe one moment. Let's see. Okay. Let's write.
No. Just accept 2 neural network.
Just accept neural network. Okay. If we add, you can see that stride equal. Sorry, not stride. We need padding. For instance, 1, and it means that we don't change our feature map. Control C, Control V. So, and it will be the second convolutional layer. And okay, 32 will be changing 32. And after this, we use max pooling and 28, and here will be 24 by 24. Okay, and the next we will add additional layers here. For example, 32 into 64 and 64 to 64. Here kernel size 3, and we add padding here, and the size 14, and it will be 14. The size don't change if you use kernel size 3 and padding 1. And 14 will be 7 by 7. And here we need to change 7 by 7 and 64 by 64 into 15. Okay, and we need to change something here, because you can see that convolutional layer, and after this max pool 1, it means that we need to rewrite it. Okay, let's write in detail maybe. We have convolutional layer equal, and after each convolutional layer we use activation function, relu activation function, conv11, and here we put the result of the first convolutional layer in the second convolutional layer, and here we return max pool after the second convolutional layer. So, and we can use the same things for the next block, 2, 2, and max pool 2. So, and here we need to change 7 and 7. So, for instance, and you can see that everything is okay now. Yeah, the size don't change. After max pooling, we decrease into times the size of feature maps, and again we use convolutional layer, but the size of the feature maps the same. Yeah, how I calculate here, because you use kernel size 3 and padding 1. Of course, better if you try to use convolutional kernel size without padding, and because you need to check correctness all the size between layers. It is very useful because you understand how they work. It is very useful because kernel size 3 and padding 1 not change any sizes here, but sometimes in modern articles you can find any blocks which consist of different convolutional layers, and the size of each feature maps can be changed, and it is useful when you understand how the feature maps can change, and after this you can just put some changes in your code and understand what's happened here. But such block, it is a common block for most popular article, I guess. But this is the most popular block when you use just the two convolutional layers and max pooling. sometimes instead of, maybe not sometimes, oftenly instead of max pooling, you can use convolutional layer like this. Okay, let's write something. Convolutional layer using stride equal to using striding you can decrease the size of feature maps, decrease in 2 times, because you use kernel size 3, for instance. Here, if we write so
Stride like step.
Yeah, it is a step. It means that if you want to decrease your feature map, sorry, I forget this one and this, yeah, this one and this. For instance, you okay, I should remember, maybe better use kernel size 2 by 2 or 3 by 3, but this one will be work too. It means that you convolute your feature maps with kernel size 3. It means on the first step you put your kernel size here and calculate the first value. This using stride 2, it means that you are going into this position and you put your kernel size here, and you calculate the second value. Stride 2 means that you are going here and you calculate convolutional here. You will get this value and go this value. So you can see that feature maps 4 by 4 now transform into feature maps 2 by 2, and it is the same as you can get less feature maps in 2 times. Means 14 on 14 will be 7 on 7 if you use, for example, such way. Yeah. So it is another way. Sometimes I implement this one instead of max pooling. I don't like max pooling, but maybe max pooling is more understandable for beginners, because here you just you have feature maps, for example, 4 by 4, and it means that you get kernel here and you just get the maximum elements. For example, this element maximum, so you just create first value. Yes, this value. After this, you have a striding 2 by 2. You can find max element. For example, this max element, so it will be this one, and etc. So you will get the feature maps 2 by 2, yeah, because max pool divided d, 2 and 2 means that you are going with kernel size 2 by 2 with stride 2, yeah, because you have this kernel size 2 by 2 and striding by 2. So, and you will get the same feature map, but this way, when you use convolutional, it means that you can combine all values from your feature maps using some weights. Here you just get maximum elements. Here you calculate this value. For example, this value combine these 4 elements here, because these elements are 0. and you use some weights for calculating this new value. And for getting these elements, you just use these elements with combination with some weights. Yeah, and I guess it is maybe more better because you use information about neighbors pixels, and this one, yeah, neighbors pixels, and you will get new value here and here. So for me, preferable use convolutional one 2D using striding and some kernel size. So of course, it is just one big lecture in computer vision because I guess that understanding how the convolutional layers works, it is most important things, and of course you need you should understand what does mean padding, kernel size, and striding. Three properties, 3 parameters, very important for convolutional layer task. So now commented. So now we have fine model, and okay, let's see. And the second value error expected input size batch 4 to match target batch size 64. So let's see what's happened. Okay, this picture just shows us probabilities of each classes. Yeah, it means that we have some instance, for example, 0, 1, 2, 3 instances, and this is the probability of all classes. You can see that now our model don't
10.
know each. Yeah, 10 classes here. It is a
Yes.
class. So, and now model don't know which classes for this instance, or for example for this instance, because you can see that this probability and this probability is maybe equal, and we don't any our model just says that it is not 8, yeah, because 8 is around 0, but other classes is has equality. Yeah? So okay. So model, let's run, and now we can train model and just using any apple. Now we have apple 50 apple, and we can train our model. And plot curves. Expected input size batch 6 to match target batch size 64. Okay. Log interval. And learning rate now 10 in power of -5. So with such learning rate, the training will be slower, and you can see that the loss function doesn't change. And we have test sets. Okay, maybe let's try to use higher learning rate, for example, -3, and then log interval. Let's for So for analysis model, you should use curves which will be plotted in real time. Means that when you create model, you just you need to check how the model works, and using just the numbers is not good, but because you need to check curves. So I guess that we need to finish for today, but because now we have a lecture,
Do you hear me?
Yes, we have a meeting.
Yeah. Okay. And today we have a webinar, COVID-19 strain virus detection. It will be considered the application of modified recurrent neural networks and pre-training methods to detect the COVID-19 virus. And we will start after 15 minutes. I send you can see at the YouTube channel. And please don't forget, you can ask your questions in the chat broadcast, and I will ask after the lecture to Dr. Asadi Srivanasulu. Okay?
Okay.
Okay.
just two words. I say.
Yeah. Okay. Of course. Of course, Vasily.
Ali and the main idea that you just change the numbers, like this, 550s and 100 apples and learning rate, and you plot the curves, here, and after this you should analyze how you can train your model, how you can train, which parameters is better for training model, which is lower. It means the main idea for understand how the model works. This curves, and when you plot your model using parameters, learning rate and apple, you can estimate how the model works, and you just plot curves here, and after this analyze them. Okay.
Okay.
For any parameters, you just plot.
I just asking learning rate. I choose big or small.
So there is no. Okay, maybe it's just one.
Or middle.
One details. For instance, your loss function looks like this. Loss function, for instance, looks like this. If you stay here, I just remind you that you need to find the minimum value of your loss function, which lie here. If learning rate is less, it means you are going here, and here. Go with a small step, and you find, but the training is slower. If you use biggest learning rate, it means you can go here and go again here, go here, and you just jumping here, no, but you can't find the loss, the minimum value of your loss function. You can. So you should correctly find learning rate. It means not higher, not lower. You can find. And here we just change learning rate and see curves, and determine or check this learning rate. Okay, so just try to change learning rate and apples and plot curves. Okay.
Okay, thank you very much, Professor.
So if you don't have any questions, we can finish.
Yes, we can.
Okay. So
Thank you, Professor. Goodbye.
okay, thank you too.
Bye bye.
Thank you. Bye.
Goodbye.
Bye.